In this video, we're going to look at two final examples on integration using partial fractions, particularly what I'm going to call top-heavy fractions. So essentially, if you look at this first example, we've got a quadratic on the top, and there's also a quadratic on the bottom. So the form that we're going to need to write this one in, we're going to have to be really careful with. One thing to spot, the denominator is a difference of two squares. So 9x squared minus 4, we could think about that as 3x plus 2 multiplied by 3x minus 2. And what I mentioned in the last video, don't forget, like this fraction, it is a division, it's something divided by something. So you could think about it if you wanted to as 9x squared minus 3x plus 2. And that's being divided by 9x squared minus 4. I'm not going to do the full division for this one because I think partial fractions is quicker, but it is really worth bearing in mind that like I actually know straight away what one of my constants is going to be. Like the first step on the division is to do 9x squared divided by 9x squared, and you would be left with 1. Like that there is your quotient. So the form that we're going to need to write this one in would be equivalent to a plus something over 3x plus 2, so b over 3x plus 2, plus c over 3x minus 2. But I would straight away be able to look at this and just look, by comparing the leading powers of the highest power of x, 9x squared divided by 9x squared is 1, so this a here, there's no harm in just writing that down as the number 1 in the exam. Like they wouldn't mind if you just by inspection were able to figure out what that was. Okay, so now we need to do the partial fractions, and we're going to compare the left hand side. So 9x squared minus 3x plus 2. I'm going to skip that step because we've done it a few times. So 1 would be multiplied by 3x plus 2 and 3x minus 2. B would be multiplied by 3x minus 2. And c would be multiplied by 3x plus 2. You will notice that this will disappear both times. Like when we sub in the two values of x, this bracket will always disappear. All we need to do is figure out what b is and what c is. Okay, just be careful again when you're thinking of what value to sub in. Don't sub the wrong x value in. If 3x plus 2 would equal 0, we're going to have to sub in x equals minus 2/3. Okay, so if x equals minus 2/3, sub that into the left hand side, and we get 8. Sub it into the right hand side, that would become 0. Minus 2/3 into this bracket, so minus 2/3 times by 3 would be minus 2, minus 2, minus 2, minus 4. Minus 2/3 into this bracket, it would disappear. So we've got 8 equals minus 4b, so minus 2 equals b. And then similarly, if we let x equal 2/3, because we want this bracket to disappear. And when we sub it into the left hand side, we end up with 4. Sub it into this, we get 0. Plus b times 2/3 into this becomes 0. And plus c. Okay, so 2/3 times by 3 would be 2, 2 plus 2. So 4 would equal 4 times c. C would equal 1. Okay, so now we've got this fraction here that we couldn't integrate. We know what it's equal to. We know b is equal to minus 2. And we know c is equal to 1. If you do get a question on partial fractions in the exam, please highlight the final answer. Like, this is key to moving on with the rest of the question. Okay, so we're not going to integrate this. We are going to integrate these fractions. Okay, so this original integral here, remember, is the same as integrating these separate fractions. First on integrate 1 with respect to x, we just get x. Be careful with this one, okay? The derivative would be 3, so I need to rewrite this so that there's a 3 on top. I'm going to do two things in one. I'm going to take the minus 2 outside. So if I do take that minus 2 outside, remember, it's minus 2 times by 1, so at the moment I've got 1 on top. If I would like there to be a 3 on top, then I multiply the top of the fraction by 3 and balance that out with a 1/3 outside. If I multiply minus 2/3 by 3, I get the minus 2 that I started off with. Remember, all we're doing is rewriting it in a different way. Okay, for this one, we would like there to be a 3 on top. So if I multiply the top by 3, I have to balance that out with a 1/3 outside. Okay, so we would end up with integral 1, which is x. This integral with the derivative on top, so minus 2/3 ln modulus 3x plus 2 plus 1/3, and then this integral ln modulus 3x minus 2 plus c. Final example, we've got 2x cubed minus x squared minus 4x plus 2, all divided by x squared minus x minus 2. Very careful with the form for this one, because we've got a cubic. Oops. Cubic divided by quadratic. So the form for this one, we're going to end up with ax plus b, and then this quadratic factorizes into x minus 2, x plus 1. Okay, so because the power on the top is higher, you will get a linear function when you do this division. If you think about it, a cubic divided by a quadratic would leave you with a linear function, wouldn't it? I would strongly recommend that we do algebraic division for this one. Okay, so the first thing I'm going to do is divide. Give yourself enough space for this. 2x cubed minus x squared minus 4x plus 2, and we're dividing that by x squared minus x minus 2. 3 steps is algebraic division. Remember, you always focus on the leading term. So 2x cubed divided by x squared would give me 2x. That's the first step. Next step is to multiply everything. So 2x multiplied by this will give me 2x cubed minus 2x squared minus 4x. And the third step is to subtract, but just be careful when you subtract with the negatives. They should always cancel. That minus that. Now you've got to be careful with the negatives. Minus becomes plus. So plus 2x squared and minus x squared would be x squared. Minus 4x minus is plus. So minus 4x plus 4x becomes 0. And then plus 2. Last step, do one more division. X squared divided by x squared would become plus 1. And then multiply, so that would be x squared minus x minus 2. Subtract. They cancel. 0 minus minus, so that's plus x. 2 minus minus, so that's plus 2, so that's plus 4. Okay, so what we've got at the top, that's our quotient. So that 2x plus 1 is essentially the ax plus b that we were trying to find. And our remainder, x plus 4, is going to form this 2 separate fractions that we need to find. Okay, so basically what we now know by this division is that this divided by this is equivalent to, at the moment, we've got quotient, which is 2x plus 1, plus our remainder, which is x plus 4, over our divisor, which I'm going to think about that as x. Instead of x squared minus x minus 2, I'm going to write it as x minus 2, x plus 1. So when you do the algebraic division, you get 2 of the values straight away. The quotient is this part. And then this last step is a quick partial fractions question, because we can compare. We don't need to actually worry about the whole thing anymore. Like, that there is equivalent to that there, isn't it? So all I need to do is split this up into this form. So dead quick partial fractions, x plus 4 would be equivalent to, if I compare this with this, c would be multiplied by x plus 1, and d would be multiplied by x minus 2. If x equals 2, I'd get 6 equals 3c. If x equals minus 1, I'd get 3 equals minus 3d. So c equals 2, d equals minus 1. And we've got everything we need. Okay, so this fraction, this horrific looking fraction here, is just the same as 2x plus 1 plus c, which is plus 2, divided by x minus c plus d, which is minus 1, so minus 1 over x plus 1. And all we've now got to do is integrate those separate terms. Okay, so final step, just to integrate. Add 1 to the power divided by the new power, so that'll become x squared, plus 1 would become plus x. And then we should be getting used to this by now, but the derivative would be 2, the derivative would be 1. Take the 2 outside. 2 times 1 is the same as 2 that we had. Derivative for this would be 1, so just take the minus outside, and you've got your derivative on top. So that would become plus 2 ln modulus of x minus 2 minus ln modulus of x plus 1 plus c. Okay, so have a go at a couple of the questions on exercise 1. Check the work solutions, check the answers as well provided. And then once we've done that, we've basically seen like basically all the integration techniques in A-level. We've then got to look at one last application of integration, which is differential equations, and that'll be on the next video. Thanks guys.